In the next several minutes, I'm going to tell you everything you need to know about how decentralized identifiers work and how they are changing things. I'm going to go through a specific use case. Let's get into it. Decentralized identity is about an individual taking back custody of their data and of their identity. Right now, we are using centralized identifiers, and our identities are mediated totally by a centralized company or service. They control our application data, they control whether or not we're allowed to use this data, and we have to rely on inputting our credentials into those services to get access to them. A decentralized identity takes that back, and so it all starts and is centered around a decentralized identifier. This is kind of like a URL. A URL points to a specific website, but a DID points to a specific person or other entity. It could be an IoT device, it could be a company, an institution, a government, it could be anything. But a DID is the central identifier of the decentralized identity ecosystem. Now I'm going to show you this schematic here, and I don't want to go too far in detail about things because it gets deep into cryptography, and we don't really care about all of the back-end components. But I told you, a DID is an identifier. It refers to a subject such as a person like myself. Then there is a DID document that the DID resolves to. The document contains the public key and verification method needed to verify that a person or entity actually controls that DID. So there's a private and public key pair in the background, very similar to how crypto wallets currently work. And if I sign a message with my private key, any third-party verifier can look at that signature and then compare it to my public key, which is publicly available, made available through this verifiable data registry, I'll have you know. And anybody can verify this through cryptography that I was the one controlling the private key, therefore I control this DID. So I've explained decentralized identifiers and the overall DID ecosystem with DID documents that are backed up on the verifiable data registry. This is how DIDs can be discovered by other entities and how you can interact with them and verify them. But you kind of wonder what all this might be used for. And let's think back to the real world and what we have right now in our physical wallets. We have a driver's license, we've got library cards and medical insurance. And these physical documents make claims about who we are and the services that we have access to. So a driver's license explains my name, it explains the state that I live in, and it also would tell a police officer, if he were to pull me over, that I am authorized to drive on the road, that I have gone through the necessary steps and training in order to legally drive on Texas roads. So now I'm going to introduce something new called a verifiable credential. This is exactly the same as the physical documents that I just described to you, except verifiable credentials are digital and they are associated with a DID. So they make claims and assertions about a specific DID. So you could imagine a DID that is related to a university student. You're going to have like what school they enrolled in, when they first enrolled, and then also when they graduated, and then a VC like with their diploma. And this VC could be used to show employers in the future, and employers would be able to verify that you did indeed get a persona with a certain diploma with a certain grade point average from said university that you're claiming. Now, the important thing to understand is that DIDs are publicly available. We want people to be able to discover these entities in order to be able to interact with them. But VCs are held in DID wallets, and by default, they're private. They're not publicly exposed because these make critical claims about yourself. You wouldn't ever want to publicly expose your social security number, but you do need to give your social security number to trusted institutions at some points. So let me explain at a high level what the verifiable credential flow looks like. You have institutions that issue a verifiable credential. This could be the state of Texas issuing me a driver's license, but it's in digital form. And this driver's license VC gets held or stored in my wallet. And then if a police officer pulls me over, then I can choose to give him this digital VC, and he can verify everything digitally through cryptography. And what he's verifying specifically is that this VC is valid and that it was issued by the state of Texas and that it was presented to him by the correct holder, which is me. So let's talk about a specific example. I want to prove that I have a bank account to Acme Bank. So Acme Bank issues me a VC. And within this VC, you have the bank's DID, you have the subject's DID, which is me, you have the claims, which is like the account number and then the name on the account, and then the issuer actually signs this VC. They have a private key and they sign this document. And this is cryptography, so we're not going to go into the details, but just understand that this is a data packet that then gets sent to my digital wallet. I hold my digital wallet, and then I want to prove that I have a bank account with to this PFI verifier, participating financial institution, I believe is what that means. So what I do is I bring that VC up, and then I also sign it. So now we have the VC, we have the issuer's digital signature, which is this bank, and then we have the subject's digital signature, which is my digital signature. So my DID wallet signed this VC with my private key that controls my DID. And we send this data packet over to the PFI verifier. Now, what the verifier does is the verifier needs information, more information about our DIDs. It can see that it contains two DIDs, an issuer and a subject. And the verifier wants to verify the digital signatures, these two right here. So it uses these DIDs and it queries the verifiable data registry to get my DID document and then the bank's DID document. And within those DID documents are our public keys, and so it can say, okay, here's a digital signature, here's a public key, and it can check that those were compatible or through cryptography that that was a valid digital signature. So just like in crypto, the DID wallet is going to be the central interface on how a user interacts with the DID ecosystem. So crypto wallets allow users to interact with a blockchain and decentralized applications, and DID wallets allow users to interact with the DID ecosystem. Eventually, I believe that crypto and DID wallets are going to come together, and they're going to, when a user onboards, a blockchain address and a DID are going to be created both at the same time. And with this digital wallet, we'll be able to store and manage our VCs. If somebody asks us for verification, we're going to be able to present a VC to that person. If we want to verify another DID, then our wallet will also will be equipped with this cryptography. We're going to be able to also sign into decentralized applications, and I'm going to get to that in later videos. Thank you.